magnetic field lines and its properties. So we will define magnetic field lines just we defined an electric field lines in electrostatic. Okay, so now if you remember in electrostatic, right, the electric field lines, it is the curve or the path along which a unit positive test charge would move if it is free to do so in the regions of electric field. So likewise, this magnetic field line, it is the curve or the path along which a unit north pole would move if it is free to do so in the regions of magnetic field. The tangent at any point, right, to the curve always give you the directions of magnetic field. Alright, now what are the properties of these magnetic field lines? Okay, suppose this is a bar magnet in which this end is a north pole and this is a south pole. Then these magnetic field lines, they always, starts from the north pole, okay, and enter the south pole. And this is actually, right, is taking place outside the magnet. So outside the magnet, this line, it is going from north pole to the south pole, and inside the magnet, the line is moving from south pole to north pole. Okay, like this. So therefore, I can say that because the line here, right, outside the magnet is from north to south, but inside is from south to north. So therefore, this magnetic field line is a closed curve. So that is the first property. The second property of this magnetic field line is that the magnetic field lines cannot cross each other. Okay, suppose if you have two lines intersect or they cross at one point, then at this point you will have two tangents. One is to this curve, another tangent is for this curve. So two tangents at one point, it would mean two directions of magnetic field. But the direction of magnetic field, right, it cannot be more than one. Okay, because magnetic field is a unidirectional quantity. So therefore, two lines of magnetic field, right, or two magnetic field lines cannot cross each other, because if they do so, you will get two directions of magnetic field. Okay. And the third important property is that these magnetic field lines, right, they leave or they enter the magnet normally. Like if this is my magnet, then this line, right, it leaves this magnet. At this point, you will see this is perpendicular. This line is perpendicular. This line is perpendicular. So similarly, when they enter to the south pole, you will find that they enter it normally like this, perpendicular to the magnet. Okay. Now, the fourth property is that, right, the relative closeness of these lines, it gives you the strength of the magnetic field. So if the lines are close to each other, so at that region, the magnetic field is very strong. Okay, so you will find here that at north pole and at south pole, okay, the lines are very close to each other. So which means at these two regions, the magnetic field is very strong. However, if you are going away from the magnet, then you will find, the distance between the line is large. So when the distance between the line is large, it means the magnetic field at this region is weak. Okay, so these are about some of the important properties of the magnetic field lines.